Welcome to lesson 2.1. We are kicking off unit 2 by talking about relations and functions. Today there's going to be a lot of key terms, so make sure that you're pausing the video as needed to take notes and make sure that you have a good understanding of all of these key terms. So here's a list of our key terms, and the first one we're going to look at is relation. A relation is a set of input and output values, and it can be written as a set of ordered pairs. So this would be a relation. It's a set of ordered pairs. We have inputs and we have outputs. It's important to remember that when we're thinking about relations, our input is like, if you think about like a machine, an input is what we put in this case x, and then the output is what we get out, in this case y. So we are going to graph the relation. We've got 0, 1. We've got 3, -4, -2, 2, and -5, 0. Now we're going to label the pairs. So I'm going to label these just with what point they are. Be careful with the ones that have the points that have a 0 in them. A lot of times I see people mix those up. I think we do pretty well when it's something like 3, -4, but a lot of times people will graph 0, 1 as this, and they mix up their ordered pairs. So that's how we would graph a relation. So it doesn't really seem like much, but let's get a little further into it. The domain is the set of all inputs, or all x coordinates, and the range is the set of all outputs, or y coordinates. You can come up with whatever way you want to remember this. The way that I remember it is that domain and range, dr, goes in alphabetical order, and so does x, y. If you come up with a great way to remember this, let me know, because I'm always on the lookout for good memory tricks. So domain is x, range is y. And a mapping diagram is a way to display a relation and to connect inputs and outputs. And we'll take a look at that here in just a second. Find the domain and range from the given ordered pairs, then make a mapping diagram. So first of all, domain is all of my x coordinates. So if I look at my x coordinates, I've got 2, 1, -7, -9, and 1. But, so with my domain, I start out with what I call face brackets. I call them face brackets because it looks like a forehead, a nose, and a chin. I think they've been called braces, brackets, it doesn't really matter, but you need to make those little face brackets. And then for our domain, we're going to put these values, these x coordinates, in numerical order, so the least to greatest. So the smallest would be -9. The next one would be -7. Next we'd have 1, but notice that we have 1 written twice. When we have an input or an output, an x or a y coordinate, that occurs 2 times or more, we only write it once. So instead of writing 1, 1, I'm just going to write 1. And then I'm going to have 2. For my range, start out with those face brackets. And let me actually change color. Let's look at our y coordinates. So my least value here is -8. Then -5. If you need to cross them off as you go to make sure you account for everything, that could be a really good trick to use. -4, -3, and 5. So there's our domain and range. And then it says to make a mapping diagram. And a mapping diagram is going to look like this. You can do rectangles. I just tend to do ovals, where the left one is our input and the right one is our output. So in the input, I'm going to put all of my domain values in order from least to greatest: -9, -7, 1, and 2. And then I'm going to switch over here, put my output values: -8, -5, -4, -3, and 5. And now we are going to connect those And here's what we're going to do. We're going to say, okay, when I had the input of -9, what was my output? And if I look back here, when I put -9 in, I got -8. So I'm going to draw a line from -9 to -8. You don't have to put the arrow on the end if you don't want. You could just draw the line. When I put -7 in, I got -4. So that would go like this. I like the arrow on the end. All right, now with 1, remember it happened twice. So we had, when we put in 1, we got -3. But also when we put in 1, we got 5. So 1 is actually going to have 2 arrows coming off of it. And then last but not least, when we put in 2, we get -5. So we're going to draw a line from 2 to -5. And that's how we would do a mapping diagram. A mapping diagram is just showing us if we put the numbers in order, which numbers connect and how are they connected. A function is a relation where each input has exactly one output. So for every number that I put in, I get exactly one value. So if you look at this, do you think that this would be a function? It actually would not be a function because if we draw a line from 1 to 5, I also have a line coming from 1 to -3. So that means that the value of 1, or the input of 1, has 2 outputs. And it says that a function has, each input has exactly 1 output. So let's look at a few more examples. We're going to practice with these mapping diagrams. You don't have to write out the domain and range on these, but I'm going to go ahead and fill in my values. And again, they do need to be in numerical order. So if I look at my x-coordinates on letter A, I get -8, and then I get 1, 5, 6, 9. And then when I fill in my y-coordinates, I would get -3, -1, I would get 2, and 9. Now 9 repeats twice in the y, so I'm not going to write it twice, I'm just going to write it the one time. Then on this one, for our x's, we would start out, or for our inputs, excuse me, we would have -9, -3, it's written twice, but I write it once, and then 3 and 4. And then on our outputs, we would have -7, 4, 5, 7, 8. Now comes the mapping part. We've got -8 goes to -3, 1 goes to -1, 5 goes to 9, 6 goes to 2, and 9 also goes to 9. Over here, when I map these, -3 goes to 4, -3 goes to 7, -9 goes to 8, 4 goes to 5, 3 goes to -7. So looking at your mapping diagrams, are one or both of these or none of these functions? And why or why not? I'll give you a hint. Only one of them is a function. So the only one that's a function is actually letter A. Now, if I look at this, you might be tempted to say it's not a function because 9 has 2 lines coming to it. But remember, the definition says that each input has one output, exactly one output. And if I look at my inputs, there's one output here, one here, one here, one here, and one here. None of my inputs go to more than one number. So an output can have more than one number coming to it, but an input cannot go to more than one number. Whereas here, this -3 goes to 2 different numbers. It goes to 4 and to 7. So therefore, it is not a function. The vertical line test, this is probably something familiar to you, but it's just a method that we use to tell whether a relation is a function. If we graph a relation, then the vertical line test tells us that if I draw a vertical line anywhere, I know that's not perfectly vertical, but we'll use our imaginations. If I draw a vertical line anywhere on this graph, it should only ever cross one point. And I just drew a bunch of vertical lines, and if I check here, 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 that red line is my graph, and it's only ever crossing those vertical lines at one point. So this one is a function. We can say, yes, it's a function because it crosses at each part of the graph at one point. But if I draw vertical lines on this one, right away I should see that it doesn't matter where I draw my vertical lines actually, it's crossing at 2 points. So this one would be not a function because it fails the vertical line test. It touches at more than 1 point. All right, last thing is function notation. We're going to write it like this. It's going to look like f parenthesis x parenthesis, but we read it as f of x. So whenever you see this, I want you to get in the habit of reading it f of x. And it's used to show that a relation is a function. So mathematicians will use this to just go ahead and define that something is a function for you so that you don't have to determine if it's a function. So these are all actually examples of function notation. It's not always f of x, but these would be our outputs. And these are right here, these are the kind of equations we're going to look at a little bit more throughout this unit. X is going to be our input. So what this function is saying is, when I put in a value for x, what do I get out for y? And that's what makes x our input and y our output. If we think about the formula for the area of a circle, we would say, what is the area? Well, in order to know the area, I have to know the radius. So that's kind of a hint for determining which one's your input and which one's your output. Which one determines the other? Radius determines what our area is. X determines what our y value is. And so you can see here the example of function notation with f of x. F of x and y are actually interchangeable. We can switch them out and use them interchangeably. So when you see something like this, it's saying, okay, you have a function, and here is your function, 5, 6, x minus 3. And when we read this, we read it as f of negative 3, f of 0, and f of 2. What this is saying is find what happens when x equals negative 3, when x equals 0, and when x equals 2. So let's try this first one together, negative 3. I'm going to actually replace my f of x with f of negative 3 and write it like this. Now, we don't like fractions. I know, well, you guys don't, I do, but we can work with this. This is going to give me a 2, and then I'm going to have negative 5 halves minus 3. We're going to leave it in fraction form the whole time. So I can rewrite 3 as 6 over 2 so that they have a common denominator. And I would get that f of negative 3 equals negative 11 over 2. And we're going to leave our final answer like this because it's actually answering the question of f of negative 3. What is it? It's negative 11 halves. So please include this in your final answer. If we do f of 0, we're going to get 5, 6 times 0. Well, that's just 0 minus 3. And that's going to equal negative 3. So there's my answer. Try f of negative 2 on your own. So if you check your work over here, when you plug in 2, you should end up with 5/3 minus 3. I changed that to 9 over 3 so that there's a common denominator. Subtract those, and I get negative 4/3. So this has been just kind of a brief introduction into functions and relations. Please let me know if you have any questions.